Unit 1, Lesson 20, Transformations, Transversals, and Proof. So our learning goal is let's prove statements about parallel lines. So in our warm-up for math talk angle relationships, they say, or they give us, that lines L and M are parallel. So they said mentally evaluate the measure X in each figure. So in figure A, what do you see right away? Okay, so what do you think about X? Do you think it has something to do with the 40 degrees here? All right, if you say immediately that X is 40 degrees, good for you. Good for you. Because they do tell us that L and M are parallel, and the title mentioned transversals. Line P, which cuts through both these parallel lines, L and M, that is a transversal. Okay. Next figure. What do you think X is? So pause the video, use your best guess. Okay, so hopefully you paused it and you thought maybe 61 degrees. So X is 61 degrees. That would be correct. Figure C. This is slightly different than the first two figures. We have 98 degrees in here. What about here? Now, what do you think? Do you think that these two angles are the same? Or do you think that these two angles, X and 98 degrees, have to add up to 180 degrees? All right, so what do you think? All right, if you said that they have to add up to 180 degrees, all you had to do was take 180 minus the 98 that's here, and that should give you the remainder for your degree for X. Figure D, what do you think? What do you think? So we know about vertical angles from last lesson, right? So if this is 125 degrees here, then its vertical angle is also 125 degrees right here. Now, the question is this angle that my cursor's on the same measure as X? Okay, so if you said yes, and X is 125 degrees, good for you. Good for you. All right, so 20.2, make a mark, give a reason. So I am offering a GeoGebra attachment to today's lesson involving this image, all right, this figure, I should say. So please follow along with me on GeoGebra, and then whatever you end up constructing with following along with me, please screenshot those and turn those into me. Okay, so let's take a look. Lines A and E and C, D are intersecting lines. That means they cross one another. Okay, first things first, they want us to translate lines AE and CD directed by the line segment B to C. So this is a translation. So let's do that first part. We have a line. Let's make it red. And notice they want us to take this line and they want us to travel down along B to C. So where AE was, now it's moved down here. Notice how, and of course, I did not use constructions. I don't have construction tools like you will for GeoGebra. If you want to use constructions and the compass tool, go right ahead. You can totally do that. All right, so now they want us to also move BD down. Wait, let's see. And CD down. So if we move line CD down, all right, let's take care of, oops, let's get used to these tools here. There we go. So everybody agree that point A will be right. Trying to get it correct here. A prime is going to be right there. And trying to get my mouse, sorry. And E prime will be there. So let's use text. That's A prime right there. Okay, and then text E prime for here. And hopefully my dog isn't destroying someone right now. Let's see. All right, now it's not exact, but that's generally what a translation of AE, line AE, down, right, into the left along the directed line segment B to C, right? So we're traveling down from B to C. Now, if we were to translate CD down along B to C, the image of that line is going to be collinear with the original line CD. That means they're going to be still sharing the same place, right? Even though the line just moves down. So will the points along CD move down as well? If you said yes, good for you. Okay, that means C does translate down, right? Let's use the draw tool, or I'm sorry, the text tool. So C prime moves down. And also D, right? B is also in the picture, right? So I would imagine that B also would move down. Let's see, draw to where C is. D would also slide down to where B is. So B prime now shifts down there. And B also translates down to there. Okay, and it looks like we labeled all the new points, A prime, B prime, C prime, D prime, E prime, right? And that was just a simple translation down. Now A and E, right, compared to A prime and E prime, those lines are parallel, right? And so that would be explain your reasoning, right? So AE to line AE, those are parallel lines. How do I know? Because do translations preserve angles, and do they preserve distance? Yes, it's a rigid motion, right? So the angle, like for example, let me draw. I know for a fact that angle ABD has to be the same as angle A prime, B prime, D prime. Okay. We also know vertical angles have to be congruent. That means this angle, let's see, how should I say it? Angle B prime, D prime, E is got to be the same as angle ABD. Okay. So this angle is the same as that angle. All right. Um, this angle is also the same as those two, as is its vertical angle, angle C prime, B prime, E prime. Okay. Um, let's see, blue. This angle right here, okay, has to be the same as its corresponding vertical angle right here. This angle right here is also going to be the same as those two blue angles. And this angle right here will be the same because it's a vertical angle. Okay, so that is something to note. Now, one other thing that you should notice is when you add the one blue angle plus one of the red angles, you should get 180 degrees. Okay, so for example, if you add up, let me text this. Let's see, that pops up and is kind of in my way. So let's move it up there. There we go. So angle ABD plus angle BBE will equal 180 degrees. Let's see how that showed up. There we go. So again, that would be this angle right there. Actually, let me undo, use some red here. So the red angle, right here, plus the blue angle right here. Those two angles, when you add them up, will add up to 180 degrees. And that's the same with any of the combinations. So blue angle plus a red angle is going to give you 180. Okay. So just be aware of everything that you see here, because that's going to be the same with any pair of parallel lines with the transversal cutting through both of those parallel lines. Okay. Okay, let's move on. 20.3, an alternate explanation. So this time, they want us to use rotations, all right? They want us to rotate AE by 180 degrees around point C. Oof, so let's do that. Let me use green, and let me use lines. You get to have GeoGebra, you get to use the actual tools. So if you notice, if I rotate point A, I'm going point by point here, and I'm kind of guesstimating, which is unfortunate because I don't have the proper rotational tools for this. That's why you get to use GeoGebra for this. A prime is going to be there. Okay, so A prime is going to be right there now. We're rotating around C. And then E is also going to get the same treatment. Okay, E is way out here. If it rotates around point C 180 degrees, that's going to give you a straight line. Right, so trying to get the distance here correct. Here's hoping. So that will give us E prime. All right, let's draw A prime, E prime. All right, the line, which we're rotating all the way around 180 degrees around point C. There we go. And I'm trying to be as exact as I can. You know, I wish I could use constructions, but the tool here is not helping me on that. But yeah, so A to E, so line AE is going to be parallel to A prime E prime. Okay, how do I know that? Well, because rotations do preserve angles, right? So if you rotate a line is 180 degrees. Well, if we rotate a line, you're still going to get a line for its image. That means A prime E prime's still just going to be 180 degree, right? Line. So now let's see. Looks like they say label images A, B, C, D, E as A prime, B prime, C prime. Oh, so I think we also need to rotate the other 2 points. So let's see here. Let's rotate B and D. So B was right here. If it rotates around C 180 degrees, it'll be right here. Okay, notice how the distance is the same, right? B is existing on line AE. B prime will also exist on the new line that was rotated for A prime, E prime. So let's see, B prime. let's also take care of D, right? So D is also going to rotate 180 degrees around point C. And there we go. I'm a little off. Hold on. There we go. Okay, again, it's not exact, but that's what a rotation would look like. No idea why I did that instead of text. There we go. Okay, so nice. Do you see the transversal that was just created, right, in my lines of rotation? So let me show you what I mean. Let me draw the transversal using blue. So there's your transversal. So there is a transversal cutting through the two parallel lines. Okay. Now, what is true about AB and A prime B prime? AB right here is this segment, right? From here to there. And what about from here to here, right? What's true about them? Is their distance congruent to one another? Is A the same distance from B as A prime is from B prime? And if you said yes, good for you, right? Explain your reasoning. Do rotations preserve distance? Do they preserve rigid motion? Yeah, they do. So their distances, their lengths have to be the same. Let's see, congruent angles. So let's talk about congruent angles. Now, an important thing to note is I'm going to ignore the green lines or line segments that I created from the rotation. I'm only focused on line AE, okay? The transversal, we can call that line BD if you want. It's totally fine. And A prime, E prime, line A prime, E prime. So let's see. Does everybody agree that this angle right here is going to be the same as this angle right here? Right, those are going to be congruent. Do you agree that vertical angles are also congruent to one another? That means all those angles, those four angles that I just marked, they're all congruent to one another. They're the same measure, okay? And what about this angle here compared to this angle here? Are those angles all the same? Are they congruent? Yeah, okay. What about their vertical angles? Yep. Their vertical angles are also congruent to one another. All right. So that's pretty much the idea of a pair of parallel lines with a transversal cutting through it. Okay. You're still working with the idea that, well, you know, this angle here, right, plus this angle here, if you add those two angles up, they have to add up to 180 degrees, right, because they're supplementary. So just be aware of that. Okay, be aware of the relationships. If you add up this angle here plus this angle here, those two will add up to 180 degrees. So just be aware of those relationships. Okay, in summary, for transformations, transversals, and proofs, we dealt with the situation where we have two parallel lines, in this case L and M, with a transversal cutting through both of them, right? We'll call this transversal line EF, okay, because it just goes straight through. Now, there's several ways to explain why statements are true. We compare different ways that basically led us to understand what's going on with this. All right, we did a translation, right, of one line down to the other along a directed line. We also did rotation to show the same situation. So the reasoning behind why these angles have the relationships they have, okay, why the distance is also preserved, is because we can prove it with translations and rotations, all right, of 180 degrees. All right, that's it. Have a beautiful day.